So good day everyone, I'm Andrea Salcedo and today I'm gonna present the activity 6 which is the titration. So my objectives is to identify what is titration, the procedure of titration, and the importance of titration. So titration is a process of chemical analysis in which the quantity of some constituent of a sample is determined by adding to the measured sample an exactly known quantity of another substance with which the desired constituent reacts in a definite or known proportion. So the process is usually carried out by gradually adding standard solution of titrating reagent or titrant from a burette. Essentially a long, graduated measuring tube with a stopcock and a delivery tube at its lower end. So the addition is stopped when the equivalence point is reached. So at the equivalence point of a titration, an exactly equivalent amount of titrant has been added to the sample. So the experimental point at which the completion of the reaction is marked by some signal is called the endpoint. This signal can be the color change of an indicator or a change in some electrical property that is measured during the titration. So the difference between the endpoint and the equivalence point is that the titration error, which is kept as small as possible by the proper choice of an endpoint signal and a method for detecting it. Titration procedure. The process of titration involves the preparation of a titrant or titrator, which is a standard solution whose volume and concentration are predetermined. This titrant is then made to react with the analyte until some endpoint or equivalence point is reached, at which stage the concentration of the analyte can be determined by measuring the amount of titrant consumed. Alternatively, titration is the concept of stoichiometry that is applied to find the unknown concentration of the solution. As for the steps of the procedure, a very precise amount of the analyte is added in a beaker or Erlenmeyer flask. A small amount of indicator such as phenolphthalein is placed underneath a calibrated burette or chemistry pipetting syringe which consists of the titrant. So small volumes of the titrant are added to the analyte and indicator. This will go until the indicator changes color in reaction to the titrant saturation threshold. At this point, it will represent that we have come to the endpoint of the titration. Basically, in this case, the amount of titrant balances the amount of analyte present during the reaction. Chemical analysis. Meanwhile, the world of chemical analysis can be divided in two basic types. So the first one, we have the qualitative analysis, where one finds the composition of a compound to find what radicals are present in that salt. So the second one is the quantitative analysis, where the interest is laid upon the concentration of a known solution. So there are some fundamental requirements that should be understood before one does the titration. So the unknown concentration of a solution can be in the form of an acid, base, or salt of an acid or base. For any titration process, the method is similar except for a few differences. The titration process can be divided in the following way. So the first one, we have the gravimetric analysis, volumetric analysis, combustion analysis, and others, or spectroscopy. So titrations can also be used to furnish the purity of samples, calculation regarding pH, and etc. Any calculations during the analysis can be done in two ways. So the first one is using the mole concepts or required balanced chemical equations. Second one is the using equivalent concepts or balanced chemical equations are not required. So therefore, a sound knowledge of the concept of moles and equivalence is mandatory before studying about titration. So there are types of titration. depending on the types of reactions involved, titration can be classified as follows. So the first one is the acid-base titration, second one is the redox titration, third one is the precipitation titration, and last one is the complexometric titration. So there can be cases where the titrate can have more than one component. So therefore, based on the number of components in the titrate, the titration can be divided as follows. So the first one is a single titration and the double titration. So the acid-base titration or the acidemetoy or alkalimetry, acid-base titrations mainly depend on the neutralization between an acid and a base when mixed in solution. So more significantly, the strength of an acid is determined by using a standard solution of a base. So this process is also called acidimetry. Acids can be classified into strong or weak acids depending on the amount of dissociation to give H or ions when dissolved in water. So if an acid solution of no concentration is titrated against a strong base, the concentration of acid can be calculated considering the fact that the neutralization reaction reaches completion. So for the same fact, only a strong base is used for the titration process. So in this case, the acid solution is the titrate and the strong base is the titrant or the standard solution. So we have the redox titration. These types of titrations are almost similar to the volumetric acid-based titrations, except that here the reactions involve a redox reaction. So the interest is laid upon finding the unknown concentration of a reducing or an oxidizing agent. So the oxidizing or reducing agents are titrated against strong reducing or oxidizing agents respectively. In most of the redox titration, one of the reactants itself will act as an indicator or self-indicators, changing their color with their oxidizing states. So why do we need to perform titration in the laboratory? So the titration is a common laboratory procedure to identify the unknown concentration of a certain solution, which we often call analyte. So when titration reaches an endpoint where the color changes, we can record the volume of the titrant dispensed and use it to calculate the actual concentration of the analyte. This is the main purpose of the titration. So importance of titration in chemistry. So titration is used to determine the unknown concentration of the identified analyte. So in this type of experiment, a reagent or titrant is prepared as a standard solution. Then a known concentration and volume of the prepared titrant reacts with the analyte to determine the concentration. In titration experiments which utilize color indicators, one can tell when one has reached the endpoint of the titration when the solution changes color. In other types, a redox indicator might be used or a pH meter. In conclusion, in the process of titration, a basic solution is gradually added to the acidic solution until complete neutralization is obtained. So the endpoint of the titration is detected with the help of an indicator as color of the solution changes upon neutralization.